Assalamu alaikum, dear students. In this lecture, we will discuss geometric method of measuring price elasticity of supply. Dear students, as already discussed in our previous lecture, that there are two important methods of measuring elasticity of supply. First, proportionate or percentage method. Second, geometric method of measuring elasticity of supply. How to calculate elasticity of supply by using the percentage or proportionate method? We discussed that in our previous lecture. Now in this lecture, we will discuss the geometric method of measuring elasticity of supply. Dear students, the geometric method is a graphical presentation of the elasticity of supply. This method measures elasticity at a given point on the supply curve. That is, by using this method, we can measure the elasticity of supply at a particular point on a straight line positively sloped supply curve. Students, this method is also known as point method or arc method of measuring elasticity of supply. By using this method, the degree of the price elasticity of supply depends on the slope and origin position of the supply curve. Or in other words, we can say that geometrically elasticity of supply depends on the origin and slope of the supply curve. Assuming the supply curve to be a straight line and positively sloped, that is sloping upwards, we can conceive three possible situations of elasticity of supply. First, elastic supply, that is when elasticity of supply is greater than 1. Second, unitary elastic supply, that is when elasticity of supply is equal to 1. And third possible situation is inelastic supply, that is when elasticity of supply is less than 1. Dear students, how to calculate elasticity of supply at a particular point on supply curve? It is being illustrated with the help of a figure given in this slide. In this figure, this SS is a supply curve which is positively sloped, that is, it slopes upwards from left to right, and we want to find out the elasticity of supply at point A, that is this point, on supply curve SS. Dear students, as shown in the figure, that at point A, the price is OP and the quantity supplied is OQ. Now when the price rises to OP1, quantity supplied also rises to OQ1. That is, when price increases from OP to OP1, quantity supplied also increases from OQ to OQ1, as there is positive relationship between price and quantity supplied. The curve, that is SS curve in this figure, is extended beyond the y-axis so that it meets the extended x-axis at point L, that is here. Now dear students, from percentage or proportionate method, we know that elasticity of supply is equal to del Q divided by del P into P divided by Q. That is change in quantity supplied divided by change in price into initial price divided by initial quantity supplied. Now dear students, from the figure given here, del Q is equal to QQ1, that is change in quantity supplied is equal to QQ1. So del Q is equal to QQ1 and del P, that is change in price, it is equal to PP1. And the initial price P, it is equal to OP, and the initial quantity Q, it is equal to OQ. So del Q is equal to QQ1 del P is equal to P, P1, P that is initial price is equal to OP, and Q that is initial quantity supplied is equal to OQ. By putting these values in the formula, that is in this formula here, we get elasticity of supply is equal to, instead of del Q, we will write QQ1, and instead of del P, we will write PP1. Instead of P, we will write OP, and instead of Q, we will write OQ. So elasticity of supply is equal to QQ1 divided by PP1 into OP divided by OQ. Here in this figure we can see QQ1 is equal to AC. This QQ1 is equal to AC, and PP1, this line is equal to BC. So QQ1 is equal to AC and PP1 is equal to BC, and OP here it's equal to AQ. That is OP is equal to AQ. Now substituting these values in this equation, what we will get? We will get elasticity of supply is equal to AC divided by BC into AQ divided by OQ. That is, instead of QQ1, we write here AC. Instead of PP1, we write BC. Instead of OP, we write AQ. So our formula is elasticity of supply is equal to AC divided by BC into AQ divided by OQ. Now dear students, triangle BAC, that is this triangle BAC, and triangle ALQ, that is this triangle BAC and triangle ALQ are similar triangles on account of angle property. This angle theorem states that triangles are similar if the measure of all the three interior angles in one triangle are the same as the corresponding angles in the other. So here we can see that the measure of all the three interior angles in triangle BAC are the same as the corresponding angles in triangle ALQ. It means that angle BAC, this angle, is equal to angle ALQ, this angle ACB, that is this angle, is equal to angle LQA, that is this, and angle ABC is equal to angle LAQ. Because triangle BAC and triangle ALQ are similar on account of AAA property, this means that the three pairs of corresponding sides are in the same proportion to each other, or we can say that the ratio of their sides are equal. This implies AC is equal to LQ and BC is equal to AQ. Since both the two triangles are equal or similar on account of AAA property, the ratio of their sides are equal. So the base of this angle is equal to base of this angle, and the perpendicular of this angle is equal to perpendicular of this angle. So AC is equal to LQ and BC is equal to AQ. Thus AC divided by BC, that is this portion, is equal to LQ divided by AQ. Now substituting LQ divided by AQ for AC divided by BC in this equation, we get elasticity of supply is equal to LQ divided by AQ into AQ divided by OQ. Here, instead of AC divided by BC, we write LQ divided by AQ. So elasticity of supply is equal to LQ divided by AQ into AQ divided by OQ. Now AQ and AQ gets cancelled. So elasticity of supply would be equal to LQ divided by OQ. That is LQ divided by OQ. LQ is intercept on the x-axis and OQ is the quantity supplied or the initial quantity supplied at price of P. So elasticity of supply at any point on supply curve is calculated by the ratio of intercept on the x-axis and initial quantity supplied. In case of the figure given here, we can get the value of elasticity of supply from dividing LQ by OQ. Since in this figure LQ is greater than OQ, as elasticity of supply is equal to LQ divided by OQ. Here we'll see LQ, that is numerator, is greater than OQ, that is denominator. Or we can say numerator is greater than denominator, so elasticity of supply is greater than 1. Or we can say this curve is highly elastic supply curve. Thus we can say that a straight line supply curve passing through the y-axis or having a negative intercept on x-axis is highly elastic or simply elastic supply curve, where elasticity of supply is greater than 1. That is the case when percentage change in quantity supplied is more than the percentage change in price. Now dear students, coming to the unitary elastic supply, where elasticity of supply is equal to 1, in this case the straight line supply curve passes through the origin. Here supply curve SS passes exactly through the origin, just like SS curve in figure given here. As we know, elasticity of supply at point A can be calculated as intercept on the x-axis divided by initial quantity supplied. In figure given in this slide, supply curve SS when extended meets the x-axis exactly at the point of origin, so that both the intercept on the x-axis and initial quantity supplied are same. That is, the intercept on the x-axis is equal to OQ and the quantity supplied at price of P is also equal to OQ. So elasticity of supply is equal to OQ divided by OQ. Since OQ is equal to OQ, so elasticity of supply in case of this figure is equal to 1. Thus, dear students, a supply curve which passes through the origin have an elasticity of equal to 1. That is the case when percentage change in quantity supplied is exactly equal to percentage change in price. Now coming to the third case of elasticity of supply, when elasticity of supply is less than 1, or we can say that there is inelastic or less elastic supply. In this case, the supply curve when extended meets the x-axis to the right of the point of origin, say point L in figure given here. As we know that elasticity of supply is equal to intercept on the x-axis divided by initial quantity supplied, so here elasticity of supply is equal to LQ divided by OQ, that is intercept divided by initial quantity supplied. So elasticity of supply is equal to LQ divided by OQ. Since LQ is less than OQ, that is numerator is less than denominator, so elasticity of supply in case of this curve is less than 1, or we can say supply is less elastic or simply inelastic. In case of inelastic supply, percentage change in quantity supplied is less than the percentage change in price. So dear students, to summarize, we can say that when a positively sloped supply curve meets y-axis and on extension it meets negative side of x-axis, then in this case elasticity of supply is greater than 1, as shown in first figure in this presentation. This type of supply curve is more flat and less steep, that is this curve. And the case where elasticity of supply is greater than 1, the supply curve meets the y-axis and on extension it meets the negative side of x-axis, and this type of supply curve is more flat and less steep as compared to less elastic supply curve. Second, when a positively sloped supply curve starts from the origin, then elasticity of supply is equal to 1, or we can say it has a unitary elastic supply, and this is this curve which starts exactly from origin. And third case, when a positively sloped supply curve meets x-axis to the right of origin, that is this supply curve, then in this case the elasticity of supply is inelastic, or we can say this is the case of inelastic or less elastic supply. That is, in this case elasticity of supply is less than 1. This type of supply curve is less flat and more steep compared to elastic supply curve. Now, dear students, coming to the two extreme cases or rare cases of elasticity of supply, that is when elasticity of supply is equal to 0, and second, when elasticity of supply is equal to infinity. Dear students, when the quantity supplied of a commodity does not change at all in response to the change in its price, the elasticity of supply is equal to 0, and this is the case of perfectly inelastic supply. In such a case, the supply curve will be vertical straight line parallel to the y-axis or price axis, as shown in figure given on the left side of the slide. In the figure, SS is a perfectly inelastic supply curve which is vertically parallel to the price axis or y-axis, price axis or y-axis. In this figure, we see that no matter whatever the price level is, the quantity supplied does not change at all. That is, the quantity supplied remains constant no matter what the price level is. Now, the other extreme case, when elasticity of supply is equal to infinity, which is a case of perfectly elastic supply. Dear students, in this case, at a particular price, any quantity of the good is supplied, or we can say that in case of perfectly elastic supply, a very small change in the price leads to an infinite change in the quantity supplied. A perfectly elastic supply curve will be a horizontal straight line parallel to the x-axis or quantity axis, as shown in the figure given on the right side of the present slide, that is this figure. Here, supply curve is horizontal parallel to the x-axis, or we can say quantity axis, and this is the case of perfectly elastic supply when elasticity of supply is equal to infinity. Thank you.